Let's talk about how you'd solve a single step problem, meaning it'll only take one thing in order to solve for a missing value. Now, one thing to remember as kind of a note here on the bottom is if you had some function, and oftentimes we write a function like this, we say the function f of x is x plus 5. And if we say, well, what's f of 2? What that means is we just plug 2 in for x, and we say, well, 2 plus 5. So we just take our value and we add 5 to it. But if instead we said, well, f of x is equal to 9, what's x? We're basically saying what number goes in here that when we add 5 to it, we get 9. And you can see I've written that right up here. What number that when we add 5 to it, we get 9. Now, obviously, you can do this in your head. You just, guess and check, and it's pretty simple. You'd say, well, it's got to be 4. But in the interest of kind of relating this to problems that are going to be harder, let's talk about how you'd solve it. And it really comes down to doing the opposite. Saying, well, if I'm saying a number plus 5 is 9, really I just need to say, well, if I subtracted 5 here, basically getting x by itself, because x plus 5 minus 5 is just x, and then on the other side, 9 minus 5 is equal to 4, and you can see that's exactly what we got just thinking about it in our head. Okay, because we're solving for x. We want to say, well, what's x equal to? I know x plus 5 is 9, so what's x? In this next problem, you can see we've got 3x equals 15. Again, logic, you could run through the numbers, 3 times 1, 3 times 2, 3 times 3, 2. Well, it's 3 times 5. 3 times 5 is 15. But in order to solve for this, and again, I'm just doing this because we're going to encounter harder problems that might not come out to be whole numbers, you do the opposite of this multiplication. You'd say, well, 3 times a number is x. Well, if I want to know what x is, I have to divide. That's the opposite of multiplying, is dividing by 3. And whatever happens to one side has to happen to the other. So 3x divided by 3 is just x. 15 divided by 3 is 5, which is exactly what we thought. Okay? In this last example, I've got x divided by 7 equals 4. Again, you could kind of run through the multiples of 7 and figure out what it is. But the algebra way would be to think, well, what's the opposite of dividing by 7? If I want to know what x is equal to, I'm going to have to do the opposite of x divided by 7. Well, the opposite of dividing, of course, is multiplying. So if I multiplied, well, 7 times x over 7 is just x, because those divide out. But of course, you have to do it to the other side too in order to remain equal. Well, then x is equal to 4 times 7, which is 28. So again, it always comes down to just doing the opposite. Now, the one thing I didn't put in here, you can see I had a x plus 5 equals 9. I had a multiplication equals a number. I had a division. Of course, the one operation here I didn't really put in kind of simple algebra was what if it was x, minus 4. And let's make this interesting. Let's do a negative number like that. And we could say, well, the opposite of subtracting 4 would be to add 4. Now, let's just talk about that opposite thing one last time. The reason we're always doing the opposite is we're trying to get the one side of our equation to be x. So when we say x minus 4 plus 4, well, minus 4 plus 4 is 0, and that leaves us with just x. That's what we want. Now, negative 7 plus 4 is negative 3. Just be careful with your negatives. And there we have it. If this video helped you, please like and subscribe for more help in algebra, geometry, calculus, statistics.